Hi students, today's class is optimal page replacement algorithm. In this algorithm, so we're going to see the different technique. So we have a page replacement string, that is page reference string. So you can able to see the string. This is the string. Again, so RAM slots is 1, 2, 3. We have only 3 slots. That is size of the RAM is given 1, 2, 3. So 3 slots. Again, so we have to identify whether we are getting page fault or page hit. So that is the reason why blue color. So now I think you can able to understand this notifications, color notifications. Okay. So to make it very clear, I use the colors. That's it. Nothing else. So in this algorithm, what happens? I will going to tell you. Pages are replaced, which would not be. Pages are replaced, which would not be used for the longest duration for the time in the future. In the future, so we're not going to use that page for a long time. Understanding? So in future, okay, we're not going to use that page very long time. So that is the reason why we're going to have this technique. So in this technique, why this technique is required? So we can able to increase the hit ratio, page hit ratio. So that is the reason why this technique is compared to LRU and FIFO. This is a little bit better. So why if the hit ratio increases means the communication between the CPU, sorry, the communication between the main memory, again secondary memory, so it will going to be reduced again, so the CPU speed will going to be increased. Okay, so that is the reason why the performance of the CPU is going to be increased. That is the reason why these kind of page replacement, optimal page replacement algorithms are used here. So you can able to see here. So first one we have a page number 7. So I will going to execute the page number 7 in the first slot. So come back here. So this page is not available. That is the reason why I am going to make it as page what. Second, I want to execute 0. See here, so there are already page 7 is executed. Again, have an empty slot. I am going to execute this 0. So hence it is a page fault because it's not available in the main memory. Okay, I wanted to execute 1. So already the page is executed 7. Again 0 is executed. Again, so I will want to execute this one just because there is no pages are executing in that particular slot. This is the reason why this is also page fault. So I wanted to execute the page number 2 now. So this is the technique you need to understand very clearly. Why? Because this is the algorithm. Okay. So in this, so I will going to mark few things. See here, we have a pages 701. Yes or not? We have a pages 701. So in this pages, so what we need to understand. So if any pages is repeating in this particular string, so how long it will going to take to execute that particular page? Nothing but longest duration of time in future. So it will going to take a longest duration. Until that there is no use of that particular page in between the execution in the RAM. Okay, that time you have to check it. 0. You can able to see. Suppose I wanted to execute 2 over here in this slots. In this slots I wanted to execute 2. That time you have to check it 7. So see the 7. So next slot it will not be available. Again 3 no, 4 no, 0 no, 4 no, 2 no, 3 no, like that. So when you look at the page number 7, it will going to take a so much long time. See here, at last it will going to execute. Here it will going to execute. Again, see that 0, page number 0. So after 2, we will going to use this one. Nothing but, so before 7, we will going to execute that page. Okay. Again, you see 1. Okay. You see 1. So in this, before 7, we are using that particular page number 1, either here or somewhere here. So before 7. Yes or no? So that is the reason why. So that is the reason why we need to understand very clearly. So which one? Nothing but the pages are replaced, which would not be, so which would not be used for longest duration of time. So in these 3 pages, when you see this in these 3 pages 701, which one is the which page is taking the longest duration of time in future to execute the page means that is 7. So that is the reason why I will going to replace 7 with 2. Now I think you people are correct. Okay, yes or not? So now what I am going to do, in place of 7, I am going to replace 2. Okay, so other pages I will going to keep it 0. Okay, like same as like that 1. Again here this is the page fault. I think no problem with this. Okay, nobody have a problem, right? No, anybody have doubts? No doubts, right? Fine. So it's very clear, right? So if you understand this one, we will go a little bit further. Okay, so little bit further. So that is over, right? Again, we'll go to the page number 0. In this page number 0, so already the page number 0 is available. So hence the in these 3 slots, the page is already available in the main memory. That is the reason why no need to worry. Just make it as 2. Again, 0 is available. So 0. Again, 1 is available. 1. Again, this is page. That's why I want to write page. Okay. Again, come back to 3. Third page I wanted to execute. You have to check this 3 pages. See 2, how much time it will going to take? 2, no, here, not here, not here. Again, it will going to take after 2 pages, after 2 pages completes its execution. See 0, it has to complete the execution, 4 has to complete the execution, after that 2 will going to execute this one. Again, check with the 0. See after 3, okay, after 3, 0 will come next. Okay, so that is before 2, 0 will going to execute. Again 1, come back to 1. So here you can able to see. So 1 before 1, 0 will going to execute. Again 4 will going to execute. Again 2 will going to execute. 3 will going to execute, like this. If you move on, so here you can able to see very least one. This is 1. So that is the reason why in place of 1 I will going to mention. So that is 3. Okay. So again, rest of the things are writing normally like that. Okay. 2. So here, so this is page 1. Again, I wanted to execute 0, so hence it is available. Like write like that only. 2, 0. Again 1, 3. Okay. So hence it is page 8. Okay. Fine. Now come back here. So I wanted to execute the page number 4. You can able to see the page number 4. Here 2 is there. After page number 4, we will going to use the 2. Again, that is okay. Again, check with the 0. So 0 we will going to use after the 3. So nothing but. So you will also check with this 3. Okay. See after 4 we will going to use 2. So hence before means nothing but before 0 we will going to use 2 and 3. Yes or not? Before 0. You can have 2, 3 is there. So before 0, 2 and 3 you are using. That is the reason why in place of 0 you will want to mention that is 4. So right here 2. In place of 0, what I am doing, I will want to write 4 here. Okay. Again, I will want to write 3 here. Okay. So here, so when the page is not available, the 4 page is not available. That's the reason it is called as fault. Okay. Again, I wanted to execute 2, so no need to worry. The page is available in the main memory. That's why no need to worry. Just execute as it is. 4. Again 3. So it indicates that is a page 8. Right edge. Okay. After that, come back to 3. So already when you see this. Friends, so 4, 2, 4, 3. So I wanted to execute 3. 3 is already available. Just write like that only. So 2, again 4, again 3. Okay, so it indicates it is a page 8. Okay, just I wanted to execute now 0. So you have to check it now. So after 0, I wanted 3 is there. 3 after 0, 3 will want to execute. Again 2 will want to execute. Again 1 will want to execute. But here when it comes to 4, 4 is not available. Okay, so it will going to take a longer time to execute. So that is the reason in place of 4 I will want to replace with a 0. Okay, so 0. So this is page fault. Okay, write down 3 here. Again this is page fault. Right, make it. So now I wanted to execute 3 here. So already page is available as it is. If I write down, so 2, again 0, again 3. So this is page 8. Fine. Again come back here. So I will want to execute 2. So 2 is already available. So again 0 you write like that only. 3 you write like that only. So this is the page 8 because the page number 2 is available in the previous frames. Okay. So no need to replace it. Okay. So I wanted to execute the page number 1. You have to check with that. After 1, see in this pages 302. In this 302 pages, which is first one? Which page is executing first? Which is the last one executing? So 2. After 1, 2 is there. Okay. Again 0 also is there. Again 3 is not there. In place of 3, we are going to replace with a 1. Okay. 2. Again 0. Again in place of 3, what I am going to do? I am going to replace with 1. So this is page 40. Okay. Again here, come back here. So 2 is available already. So no need to worry. Just write down again 1. Okay. This indicates it is a page 8. Okay, again come back here. So already 0 is available, no need to worry, just write down 0, again 1. Okay, so here we call it as page it. Okay, fine, because 0 is available, right? So again come back here 1. So here also you can able to see already in previous page 1 is available, no need to worry, just replace with that page and just write down that page. This is also page it. Okay, come back to here. You can able to see this is very important. So we have a page number 7 here, right? So this one is the least longest duration of in feature. So but when you come here, so you have to look into the pages where you want to look at. You want to look over here. Okay, 701. Okay, 7001. So 0 you will want to use here, yes or not? Again 1 you will want to use here, yes. Okay, 0 you will want to use here, 1 you will want to use here, but 2 you will want to use very late. Okay, that is the reason why what I will want to do in place of 2 I will want to write 7. Again 0, again 1. So here you can able to see that it is a page fault. Okay, so now check out. Now just check it out. So see here, so we completed the algorithm. So now what we have to identify here page fault and page hit. So 1, 2, 3, 4, 5, 6, 7, again 8, again 9. So the total number of page fault is total number of page fault is equal to 9. Okay, again you have to see this one more thing, one more important thing, that is total number of this is total number of page hit. Okay, how much we will going to calculate that one, we will going to take count over here, h1 2 3 4 5 6 7 8, again 9. Yeah. Okay, total 9. So now we can able to see when you compare with LRU, FIFO, again blood is all these things. So what happens here, so the page fault ratio is reducing, again page hit ratio is increasing, yes or not? If you want I'll give a small activity. So have an activity like this, activity. So what we have a slots 1 to 3, right? So basically what you want to do, so you increase the slots here. Okay, so what I will going to say, so instead of 3 slots we are going to make him 4 slots here. Okay, so make a slot 4 slots, so like this. So again check it out with the same problem. Okay, so then you will want to understand very clearly what exactly is happening over here. So make it 4 slots, 1 2 3 4. So you can able to say I want to mention here, no problem. 1, again 2, again 3, again 4. So this is a activity. So using make the main memory as a 4 slots and use the same string, I can calculate the page hit ratio as well as page fault ratio. I think this is very clear to you people, so no need to worry. So have a nice day. Thank you.